Welcome back, everyone. In our last tutorial, we explored the basic of reflection in LangGraph, and we learned how to create the generate and reflect the tweet chains. Today, we are taking it to the next level by automating the entire process. We will build a complete LangGraph that will seamlessly handle the generation and reflection cycle. So get ready to dive into the world of automated AI self-improvement. Let's get started. In this tutorial, we will depend upon our previous knowledge of LangGraph, generate, and reflect chains. Our goal is to create a fully automated system that can generate an initial tweet, reflect on its quality, improve it through multiple iterations, and know when to stop the improvement cycle. We will depend upon LangGraph powerful structure to connect our component and create a seamless workflow. Before we dive into our tutorial today, let's recap what we have covered in our previous tutorial on LangGraph Reflection. In that tutorial, we have built two essential components. First, we created a generation chain with GPT-4o Mini that could craft engaging tweets. We designed it with a specialized prompt that understood media strategy and could create content that resonates with tech audiences. Then we developed a reflection chain, essentially an AI critic that could analyze our tweets and provide detailed feedback on elements like engaging potential, content structure, and technical accuracy. You can find the complete Jupyter notebook of our previous tutorial in the description below. I have included the full code that we wrote, including the generate and reflect chain. And if you did not watch our previous tutorial, don't worry about it. I have included a link for it in the description as well. I recommend checking it out first to get a solid foundation on the concept we are building upon today. Today, we are taking this component to the next level. Instead of manually running the generate and reflect chain, we are going to automate the entire process using LangGraph powerful graph structure. This will allow us to create an automated system that can generate, reflect, and improve tweets through multiple iterations. Alright, let's start our code. I'm using the same Jupyter notebook that we used in our previous tutorial. Let's dive into the new code that will help us automate our workflow. We will start by setting up the graph. We start by importing two essential types hints from the typing module, list and sequence. These help us write more maintainable code by clearly defining what kind of data we are working with. We also import end and message graph from langgraph.graph. The end constant will help us terminate our graph when needed, while message graph is specifically designed to handle conversational workflows. Let's run the code. Next, let's start defining our nodes. Here we are defining our generation node function. It takes a state parameter containing all previous messages in our workflow. Remember, the generation chain we created in the last tutorial. We are using that same chain here, but now it's part of an automated process. Each time this node runs, it has access to the complete history of messages, including any feedback from previous iterations. Let's run the code cell. Now let's create the reflection node. This is where things get interesting. Our reflection node does something clever with messages types. We create a mapping that converts AI messages to human messages and vice versa. But why we are doing this? Because we want the generator to perceive the reflection feedback as coming from a human. The first message, our original request, stays the same, but we translate the types of subsequent messages. This creates a more natural flow in our conversation chain. Let's run the code cell. Now we start building our graph. We create a message graph instance and add our two nodes to it, generate and reflect. We set generate as our entry point since we always want to start with tweet generation. To control our workflow, We set maximum iteration to 5. This prevents endless loops. Our should continue function checks if we exceeded this limit. If we have, it returns end. If not, it continues to reflect. We then connect everything by adding edges. The conditional edge from generate uses our should continue function to decide the next step. And we add a direct edge from reflect back to generate to create our improvement loop. And finally, we compile our graph. Let's run the code cell now. Now let's visualize our graph structure using Mermaid, which is a great tool for creating flowchart. We will use the IPython display functionality to show our graph. Let's run the code cell now. And we get our graph. Looking at the generated graph, we can see 4 key components. A start node at the top, this is where our process began. The generate node responsible for creating and improving tweets. The reflect node handles analysis and feedback. And an end node where our process terminates after reaching maximum iteration. The arrow shows us the flow of our process. We start at the top and move directly to generate. From generate, we have 2 possible passes, shown by the dotted lines. One pass leads to reflect, which then loops back to generate. The other pass leads to end, when we have reached our iteration limit. The loop between the generate and reflect continues until our should continue function determines it's time to stop. This visual representation helps us understand how our components work together in an automated cycle of generation, reflection, and improvement. Each time we go through the loop, our tweets gets better based on the previous feedback. To test our graph, we create a simple input asking for a tweet about reflection in AI. When we run this through our graph.invoke, look at what happened. I'm running the code cell now. First, we get our initial tweet generation. Then we see detailed reflection and analysis. This leads to an improved version of our tweet, revised tweet example here. The cycle continues with each iteration refining the tweet based on previous feedback. Finally, after reaching our iteration limit, we get our final optimized tweet. Notice how each iteration builds upon the previous one, incorporating the feedback to create increasingly better version of the tweet. This automated process saves us from manually running each step and ensures consistent improvement through multiple iterations. And there you have it. We have successfully created an automated system that can not only generate a tweet, but also improve them through reflection. This pattern can be adapted for various use cases beyond tweet generation, such as content creation, code review, or any other scenario where iterative improvement is valuable. Remember, the power of LangGraph lies in its ability to create a structured workflow that combines different AI capabilities. In this case, we have automated the generate reflect cycle, but the possibilities are endless. If you find this tutorial helpful, don't forget to like and subscribe to my channel and let me know your thought in the comments below. What other type of LangGraph application would you like to explore? Let me know in the comment. And finally, stay tuned for more tutorial where we will continue to explore the fascinating world of AI and large language model. Until next time, happy coding.